Okay, so let's begin with part 2 of this video of this topic, exponents and radicals. In this video we'll majorly be discussing radicals, like I've already told you in the intro. So let's begin. So this here is the radical sign. You might have seen this at a lot of places. It's sometimes called square root when nothing is written in front of the sign, and whenever there are numbers written in front outside, then it's simply called an nth root, and where n is the number written outside the radical sign. Okay, now radicals, these are actually fractional powers. Just like remember from the last video we discussed something called negative powers. A raised to the power negative b is equal to 1 upon a raised to the power of b. Okay, similarly now here radicals, let's say there's something written called square root of 3. Okay, what does this mean? Square root of 3. This means, since nothing is written outside, as a thumb rule always remember, whenever there's a radical sign and there's nothing written outside, that means it's a square root or the second root. So if it was written 3 squared, we'll say 3 squared or the second power of 3. 3 squared, 3 raised to the power 2. When we say the second root, that means 3 raised to the power of 1 by 2. That's a fractional power. 3 raised to the power 1 by 2. That's what this radical, this square root means. So in case you're given root of 4 and there's a 3 outside, that means a third root of 4 or cube root of 4, which means 4 raised to the power 1 over 3. Any number which is written, any root which is written outside, that would go in the power as 1 upon, and then that will become a exponent. This is the exponent representation of this radical expression. This is the radical turned into the exponent expression. Okay, so now there can be different expressions even in the radical. For example, they might give 3 squared and outside there's a 3. What does this mean? When you convert it to the simple exponent expression, this will be like 3 squared raised to the power 1 over 3. Or now apply rule number 6 as far as I can remember, a raised to the power b raised to the power of c, which is a raised to the power b times c, 3 raised to the power 2 times 1 by 3, or 3 raised to the power 2 by 3. This is what is the exponent expression for this radical expression. Okay, why do we convert into exponent expressions? Because it's easier to operate after that, it's easier to deal with after that. Okay, let's see some other simplifications. This is one way. We've seen the representation, now we'll see some other simplifications. For example, let's say you're given square root 24. Can this be simplified? Yes. The 24 inside can be broken down into factors. 6 times 4. This can be written as 3 times 2 times 2 times 2. Whenever the factors are inside the square root symbol, any number which is multiplied with itself, like any number for which you can form a pair inside the square root symbol, that number can come outside. So for example, I can form a pair for 2. There are 2 2's. So this can come out of the square root symbol, but the only difference being only one of the 2's would be written outside. Okay, since we're taking the square root, okay, so the pairs would be translated to ones. For example, 4 times 4, this is the square of 4. So what is the square root of this? 4. Square root is 4. Because what is the meaning of square root? A number which when multiplied by itself gives you the original number. So 4 multiplied by 4 would give you the original number, which is 4 times 4. So a 2 will come outside. 2 square root 3 times 2. Because there can be no more pairs inside the square root symbol, so this will stay inside. 2 root 6. The 6 cannot come out. There are no pairs. There are no perfect square pairs inside, just like there was for 2 times 2. Okay. Similar to this, let's say you have 6 root 48. This is the expression you asked to simplify this. How do you do that? 6, which is already outside, times square root 48, factorize 48. 48 is 12 times 4, or 6 times 12 can be broken down into 4 times 3, 4 times 3 times 4. Okay, perfect. We see a pair now, a perfect square pair, 4 times 4. So one of the 4s can come out. Why? Let's see a simpler version. 4 times 4 is a 4 squared into 3. Okay. Now just since this is actually representing an exponent expression, the only difference being that there's a radical sign, but that radical sign is just a representative of the fractional power, the root power. But the exponent rules will be followed here as well. So these two, this complete expression is having a common power of 1 by 2. 6 times 4 squared times 3 raised to power 1 by 2. That's what this radical expression means. That's what it's indicating. Now we can use rule number 2. Same power, different bases. 4 square raised per half times 3 raised per half. Okay. Now 6 times 4 square raised per half. 4 raised per 2 times 1 by 2, which is simply a 4, times 3 raised per half. See, this is why we take the one number outside, like the 4 we were taking outside. Now you can see the exact process of it. Why are we taking it outside? So 6 times 4 is a 24. 3 raised per half, 3 will stay in the square root. So that's the answer. 6 square root 48 is basically 24 root 3. This is the simplified version. Okay. So I'm hoping this is pretty clear to you. This is a very fundamental concept and there should be no confusion at all here. So maybe rewind the video, rewind 20 seconds back and play it again to see you've gotten this properly. Okay. Anyways, in case of any doubts, just write in the comments. Yeah. Okay, so this is one thing. Now, just like I said, since radical symbol, that's just a representation of fractional powers. So all the exponent rules are also followed in radicals. For example, a times b, root of a times b. This means root of a times root of b. They can split. The same exponent rule, splitting and merging. This here is splitting, this here is merging. Then square root of a over b. This is equal to square root of a over square root of b. Again, just like the exponent rule. Okay. And then nth root of a raised by b. This is simply a raised by b over n. Why? A raised by b times 1 by n. That's why b over n. Okay. For the nth root. This is the simple exponent representation of radical expressions. Okay. I don't think any other rules in radicals are left. See, the best simplification which you can do for a radical is to understand that a radical is nothing but a different kind of representation of the same exponent function. The only difference being that radical expressions, those are having fractional powers. That's why they're called radical expressions. Okay. Let me take a quick look and just review to see if we've missed out any rules, and then we'll proceed to practicing some good questions. Okay. In the last video we didn't do many questions, so in this one we'll do both exponents and radicals, beginning from easy to medium to difficult. Okay, we've covered pretty much everything. Okay, here's the first question. So we need to simplify. The given expression is x raised by negative 2 times x raised by negative 6 times x raised by 4. Rule number 1 of exponents: x raised by a times x raised by b is simply x raised by a plus b. So following that, x raised by negative 2 plus minus 6 plus 4. This is going to give us x raised by negative 8 plus 4, or negative 4, which is also equal to 1 upon x raised by 4. This is the simplified version. Okay, next one. Okay, the second question: 3 times x raised by 4 times x over 3 cubed. The most important factor, like the important key, lies in taking a good careful look at the expression, okay, so as to not miss any details. In this case, in the first parentheses, only the x has a power, but in the second parentheses, x and 3 both have the power. So let's write that clearly first. 3 times x raised by 4, this is the first parentheses, times x raised by 3 over 3 raised by 3, rule number 2. since the powers are same, bases are different, they can be done like this. Okay. Now, similar to algebra, how you do it in algebra, you operate the like terms together. Okay. So in this case also, that's the same thing. The variable parts would be dealt with separately. The constant part would be dealt with separately to simplify. The root can be chosen by us. So what I choose is x and x, we deal them together. Why? Because they have same basis, so the powers can be dealt with easily. So x raised power 4 times x raised power 3. Merge them, combine them. That's x raised power 4 plus 3, or x raised power 7 times 3 upon 3 raised power 3. That's what we're left with. If we put this here, this is what we're left with. Okay. Now 3 upon 3 raised power 3. Rule number 3. Division of exponent expressions with the same basis. X raised power 7 times, if I choose to represent the 3 in the numerator, it's going to be 3 raised power 1, which was the power of 3 in the numerator, minus 3 power of 3 in the denominator. X raised power 7 times 3 raised power negative 2, or x raised power 7 over 3 squared. This is the simplified version. Okay. Make sure you're trying these questions yourself. If you want to just understand through the explanation, that's fine. Otherwise, if you're practicing, do these yourself first and then only look at the solutions that I'm doing. Okay. Next, now we bring in some radicals, some good looking radicals. The ugly looking ones would come in later. Okay. Okay, so here it is. 1 upon cube root, or third root of x raised power 4. Looks like a complicated expression, but then now we've all understood how to convert these ugly looking radicals into simple exponent expressions. Okay, so first of all, 1 upon some power, like some exponent expression. So we can use the negative power thing here. How? First write this, the denominator, in the exponent form. Third root, that means 1 by 3. X raised power 4 raised power 1 by 3, which is equal to 1 upon x raised power 4 times 1 by 3, or 4 by 3. Done. Now this can be written as, it'll go on the top. Let's take this x raised power 4 by 3 on the top, and it becomes a negative power, x raised power negative 4 over 3. This is the simplified version. Okay. Next. Okay, here's a beautiful looking expression. The root of, there's a big radical symbol outside that's covering the complete thing, and then inside we have 1 upon fifth root of x. Since no number is written outside the outer root symbol, it's assumed to be a square root, or simply a 2. There's a 2 written here. Okay, so let's simplify the inside first. Let the root be outside. 1 upon x raised power 1 over 5. Then we say square root of x raised power negative 1 over 5, because we take the x to the numerator, the x expression to the numerator, so the power becomes negative. Now we factor in the square root. What happens? X raised power negative 1 over 5, complete thing raised power 1 over 2, because it's a fractional power, it's a root, so 1 over 2. Now apply the rule for a raised power b raised to the power c, which is equal to a raised to the power b times c. So x raised power negative 1 over 5 times 1 over 2, or x raised power negative 1 over 10. Let's get rid of this negative power. For a change, let's represent it as a simplified radical only. So 1 upon x raised power 1 over 10, negative power gone. Now 1 over 10, that's the 10th root. 1 upon 10th root of x. This is your simplified thing. Both of these, both are simplified. Okay, let's go to the next one. The expressions are going to look uglier. Okay, here's the big looking question. X cubed times y raised power negative 5 times 2 times x raised power negative 4y squared times 4x y raised power 5. Simplify and eliminate negative powers. So the final solution after simplification, which we need to give, should not have any negative powers. Okay, so how to get this done? Just like algebra, in algebraic expressions, you sort and club the like terms together. So here we'll club the common bases together. so as to easily operate on the powers. First, I catch hold of the x's. So x cubed multiplied by, multiplication is such a good operation, you can rearrange at your will. So I'm rearranging terms at my will. X cubed times x raised power negative 4 times x. This one, and this one. Next, y raised power negative 5 times y squared from the second parentheses times y raised power 5 from the third one. And then the constants, 2 times 4. Okay, so now operating these together, the three x's, x raised power 3 minus 4 negative 1 plus 1 0, x raised power 0 times y raised power negative 5 times y squared, which is y raised power negative 3 times y raised power 5. See, that's just, we're going in the sequence, or you can simply see negative 5 and 5, they get cancelled. Y raised power minus 5 plus 5 is 0, y squared is left. So y squared, and then 2 times 4 is 8. Here's the answer, 8 y squared. It's as simple looking as this, and you may not have guessed initially that this big expression would eventually turn out to be so small. Yep. Okay, let's go for the next one. Okay, here's the question of the day. So a raised power 3 over 2 upon b raised power negative half whole raised power 4 times a raised power negative 2 over b cubed. Simplify and eliminate the negative powers. So the final solution must not have a negative power. Since you can see the fractional powers, that means radicals are also involved here. Let's see what we can do. First of all, we'll apply rule number 2 of exponents. Basically, it applies to radicals as well. It's just a way of saying they've just created two different representations, exponents and radicals. Everything is exponents, essentially. So a raised power 3 over 2 raised power 4 upon b raised power negative half raised power 4 times a raised power negative 2 over b raised power 3. Okay, now this thing, the first one, a raised power 3 over 2 times 4, becomes a raised power 3 by 2 times 4, which is a raised power 6. 3 by 2 times 4 is a 6. Upon b raised power negative half raised power 4, that means b raised power negative half times 4, or b raised power negative 2. Negative times 4 is negative 2. Times a raised power negative 2 over b raised power 3. Now, make use of rule number 1 of exponents in the numerator and denominator separately. Let's do that. So a raised power 6 times a raised power minus 2, which is a raised power 6 minus 2, a raised power 4, over b raised power minus 2 times b raised power 3, b raised power minus 2 plus 3, b. That is it. Is that simple? Okay. So I think the questions are no longer going to be difficult to you, whether it's on exponent or radicals. The only thing which you might need further practice with is exponent equations. But anytime you find any question where you're getting stuck, just shoot an email to me directly, or just write in the comments. I'll take up a new video, or I'll discuss that question in any other subsequent video. I'll make it a point to do that. Okay. Anytime you need some extra personalized help, you can book classes with me by going to the Eduretics website and checking the classes offered, book from there, pay for it, and we can schedule a class. Okay.